In this video, we're going to look at some terms that we're going to need to know for programming with Android. We'll look at Android-specific terms, and then we'll take a look at object-oriented terms, and we'll see how they can apply to the Android programming model as well. First of all, what do we need if we're going to program an Android application? Well, we need a computer, somewhere where we can write our code, essentially. Then we need an integrated development environment. There have been several iterations of integrated development environments, from the Android SDK to Eclipse, which we used for a while for developing Android apps, but that went away several years ago in favor of Android Studio, which now is the most popular. Android Studio is a flavor of IntelliJ that's specifically meant for Android development. And Android Studio integrates together a lot of the things that you see here that we need for Android development. So, Android development tools, Android Software Development Kit, or SDK, and the Android virtual device, or the emulator, that we can use to run our programs and debug them. All of this, you can get these separately, but if you get Android Studio, it essentially integrates all of this stuff together. Now, programming language we need to choose as well. And for that, we can go with the traditional Android development language, which is Java. And in our course of study, we assume that you've already had Computer Programming 1 and Computer Programming 2, which talks about object-oriented concepts with Java. So that makes a nice fit. Kotlin has come out a bit more recently and has gained a lot of popularity because there's a lot that you can do with Kotlin that you can do in a lot less typing than you would any other programming language. So it's really quick to get something up and running in Kotlin without worrying about a whole lot of boilerplate. So both languages have their advantages. What I often recommend is that Kotlin makes the most sense after you've understood Java. In other words, you kind of understand what you're saving with Kotlin after you've done it the Java way. So a lot of times I recommend look at Java first, especially if you have a background there, then explore Kotlin. On the other hand, if you have no background in Java, might be worthwhile to jump straight into Kotlin. Really could go either way there. I could go either Java or Kotlin there. I will say this, if you're coming from iPhone, if you're coming from iOS development and you're familiar with Swift to Kotlin is a pretty easy jump to make. Swift to Java, not so easy. I mean, definitely possible, but Swift and Kotlin are very similar. So if you know Kotlin, it's easy to pick up Swift and vice versa. Now, IDE, so which one? Android Studio, we said that's the most popular. What does an IDE do? It gives us a little editor where we can write our code. It gives us a WYSIWYG editor, or what you see is what you get, where we can create our UI layouts as well. It allows us to build our projects and compile them. And we can even create deployable artifacts that we can put on the Play Store. Things like an APK, which is the traditional deployable artifact, or something called an Android app bundle, which has come out a little more recently. An Android app bundle is very similar. The difference there is that the Play Store can optimize an Android app bundle for the type of device that's requesting a download. So it can optimize the size of the images that go down, so it sends only the ones that physical device is going to use. Because an Android TV is going to use a different resolution than an Android watch or an Android Wear or something like that. So an AAB allows the Play Store to generate that on the fly, where an APK essentially bundles everything into one big package, and all users get that same package. That package includes all language extensions and all different sizes of graphics. Either one, nonetheless, our development environment can generate this for us. Now let's consider some parts of the Android development ecosystem itself. First of all, we have this concept of a layout. A layout is all the things that a user can see and interact with directly. So we have a chronometer, we have some labels, we have buttons, we have a fragment here, we have images, so on and so forth. All of these are things the user can interact with, and as developers, we're going to put this together in an XML-based layout. XML is just laying out where the items go. It's not actually doing any of the event handling logic. We'll cover that in our next discussion, which is an activity. So the idea is that somebody who's really good at graphic design, but maybe not so good at programming, can play around with this layout in an XML format and then hand it off to the developers, and the developers will write the backend that handles what actually happens when a user interacts with this layout. You see I have a sample YCWig view of the layout here, and then also you can see under the covers it's just plain old XML like we use for any other kind of XML application. So that's what the user sees. Now the activity is where we do the logic that handles things like button clicks that a user can do on the layout. So an activity is a single focused thing that the user can do. It's typically written in Java or Kotlin because we need to have some logic here that says this button has been pressed and now I want to do something. Activity and layout are generally one-to-one. There's generally one layout per activity, with an exception being fragments. With a fragment, you can have multiple layouts that swap, essentially, with the same activity. And there's no rule that says that every activity has to have exactly one layout. You could have, theoretically, you could have an activity share layouts with another activity. You could have layouts share activities. That's not common, though. One layout per activity is a bit more common. So, it handles events from the UI and interacts with other activities. And here we have an activity written in Java. You see it's just a plain old class. It has a superclass. It has interfaces. It has things like constants. It has attributes, variables, everything that a normal Java class would have. Now, broadcast receiver is an interesting concept. This is something that is made to respond to events from oftentimes the outside world. Things like connecting our phone to a charger, connecting our phone to Wi-Fi, or even things like the battery's low or we're connected to Bluetooth. Now, imagine how you can make your application respond to these events automatically without user interaction. Think about responding to, I'm connected to Wi-Fi and I'm plugged in charging. What does that mean? That means that we likely have a good deal of low-cost network, and we have a good deal of power as well. So if we have a heavy lifting task like uploading, maybe we kick that off when we hear that we are Wi-Fi connected and also connected to power. Smart things like that don't require user interaction. I'll say the first few years I did Android programming, I didn't really understand what a broadcast receiver was. Then I met a fellow Android programmer and asked him what he really liked about Android programming, and he told me broadcast receivers because it made his program so adaptable to what was going on around it. And I thought, wow, that's really neat. And that's when I decided to look into them a little bit more and found them very useful indeed. Another thing that we'll have in Android is a concept called a service, which can perform some kind of long-running operation in the background. This will typically not have a user interface. Oftentimes it's used for synchronizing data or something of that effect. So it can be a foreground service, which is where it needs to show a notification. It can be a background service where it doesn't need a notification, but it just works in the background. Or it can be a bound service where certain things are bound to it, and as soon as everything unbinds from it, it essentially winds down and it's done. So with all of these things, activity and broadcast receiver and service, we have to have a way to trigger them. And the way that we trigger them in Android is this thing called an intent. Now the textbook definition of intent doesn't really say what it is, and I'll say it confused me a bit the first few times I saw it. So an intent is an abstract description of an operation to be performed. It often causes something to happen. In other words, launch an activity, send a broadcast to a receiver, or start a service. Now here is a human. You can take a look and you see we kind of have some donuts on the right and then we have some donut holes on the left. And you've probably already mentally mapped these based on the color and the pattern. That's essentially what our Android operating system is doing. The donut holes on the left are intents, and the donuts on the right are things that will receive those intents and take some action based on those intents. So the job of the Android operating system is to match the correct intent with the correct item to be triggered by that intent. And the item that will be triggered from that intent is an activity, or in other words, a screen, a broadcast receiver, something that's listening to these stimuli from the outside, or a service, something that's going to do background work for us. So let's start with a blue donut hole. And sure enough, the Android operating system links that up to this blue donut, which is a broadcast receiver in this case. And it's saying, okay, the blue donut hole is telling me that the phone is now connected to something via Bluetooth. Now I know I need to start sending this signal to this Bluetooth speaker or this Bluetooth player. Now we have the green signal. The green signal goes to an activity, and that activity is going to appear to the user as a new screen. So maybe the user has said, yes, you can track my location, and maybe we have some location-based item that's popped up, a promotion or maybe turn-by-turn directions, or something like that where we need to grab the user's attention. Finally, we have the yellow donut hole. And the yellow donut hole finds its home, and maybe this is a service that's starting to do some kind of offline synchronization. And we talked about how we could even kind of smart that up with a broadcast receiver and have the service only eligible when we're plugged in charging and or connected to Wi-Fi, or both. So, a concept we want to think a little bit about, we'll get into this much more later in the course, but just want to introduce it right now. There's a concept of an implicit and an explicit intent in Android. With an explicit intent, we're saying exactly what we want the intent to do. We want the intent to start this activity with this specific name. With an implicit intent, we just say what we want to do, and we allow the Android operating system to decide how to do this. So we might say, I want to pick something. I want to pick something out of the pictures directory. I want to pick anything that ends in JPEG out of the pictures directory. If we say those things, the Android operating system will likely render a gallery, which will show us everything that's in our photos directory, if we wish, only with the JPG extension. So explicit intent, we're saying what class specifically we want to call. Think about when that would be used. That would typically be used within an application when we're going from one specific screen to another specific screen. Implicit intent, we're just saying what we want to do but not how we want to do it. That's usually used to call something outside of our application that we want to reuse. Something like the gallery, the camera, the video player, some kind of image viewer, music player, anything like that where we want to take advantage of something outside of our application. And think very seriously how you might use this. When I wrote my first Android application, I hand wrote everything that I needed by myself. I didn't realize I could call all these libraries that already exist on the device. The nice thing is, if I'm calling something that already exists, it's less code I have to write, less testing I have to do, and higher quality because this component is likely used by thousands if not millions of others and likely has already had a lot of kinks worked out of it. Or if I were to write something from scratch, I'd have to find all those edge cases myself. So, on to some common object-oriented terms now, and these are things that you probably have heard in earlier classes that talked about fundamentals of computing. So, a class is essentially a template. It's something that we make things out of. A class we tend to think of as a noun, like in this case, I have a canine. Now we have attributes that are variables, and these attributes describe the noun. So, a canine is going to have an age, a weight, and probably a name. And then we also have methods, which are the verbs, and those are the things that this noun, this class, can do. So a canine can bark, a canine can eat, a canine can sleep. Notice in this case, we're not giving the canine a name, we're not giving the canine an age, we're just setting up a template that will describe this canine. Now an object, on the other hand, is when we have a specific canine. In other words, the class is like a template, it can create canines. When it creates a canine, we have a specific, distinct canine. So let's see, we have a canine here named Checkers. Checkers is a female who's 7 years old and 70 pounds and has black fur. So we know these are adjectives. Name is Checkers, 7 years old, 70 pounds, black fur. These are adjectives that describe a specific canine. That's an object. We have another canine named Bugsy. Bugsy's male. 10 years old, 85 pounds in yellow fur. So you see that the value that we've assigned to these adjectives or attributes are what determine one canine from another, what can tell them apart. Canine Marino, 3 years old, 75 pounds and black fur. So we see that there's some things that the canines have in common, but some things that make them different. So essentially here what we have is 3 different objects of the canine class. Variable, a fundamental concept that we have in programming, and when I talked about attributes, an attribute is a type of variable. So when we think about a variable, we know that computers will store and interpret data as a series of zeros and ones. By applying a little bit of exponential math, we can turn those into 10 base numbers. By applying a map, either ASCII, EBCDIC, or Unicode, we can turn those numbers into letters. Or by applying a red, green, blue scale, we can turn those numbers into colors. Or we can take all of these things together and make a very complex object, like a blue Chevy Cavalier, which has a little bit of each of these together. So some strings, some letters, some colors, lots of things put together. And that's essentially how we go from this baseline of zeros and ones up to complex programs that users can interact with. So a variable can be a number, can be a name, or letters, in other words, can be true, false. The number types that we tend to see are byte, short, int, and long for whole number types. Of those, int is the most common. Byte is 1 byte, short is 2 bytes, int is 4 bytes, long is 8 bytes. For numbers, we tend to see float and double. Also, we'll use big decimal if we want to avoid something called floating point arithmetic, which is a little inaccuracy that tends to get introduced with decimal numbers. For letters, we have either character, which is char, or string, and then true, false for Boolean. So those are the different data types. In any case, when we declare a variable, we have to have a unique name, something that makes us distinct from every other variable in our program. And we also have to have a type. So we have to think name might be age, type would be int, because for age we usually deal with whole numbers. Name might be weight, type again might be int, because we tend to deal with whole numbers for weight as well. So these are the things that we need for a variable. Now, an important thing is that a variable falls into a different category depending on where it is declared. So if it is declared at the class level, in other words, inside a class but not inside a method, this is what we'll call an attribute or a field. If you hear me say attribute or field, I'm talking about this specific type of variable. The reason this is a special kind of variable is it is one of the adjectives that describes our object in the long run. In other words, a yellow Labrador, we'd want that to be an attribute. A female dog with black fur, these are all things we'd want to be attributes because they're long-lasting. Attribute variables are also available to all methods within one class. So, a lot of things we can do with attributes. Now, do we want to make all variables attributes? Probably not, because it can be a bit of clutter if we have a variable that we only need for a short time. Making it an attribute is a bit of overkill if we only need it for a temporary calculation. And also it makes our code less readable if we have things stored as attributes, which could really be locals. So speaking of which, local variable. A local variable is declared within a method. It's only usable from the point where it is declared until the close curly of the block where it is declared. Block could be a method block, in other words, the open and close curly for a method. Could be an if test block, the open and close curly for an if test. A for loop block. Any open and close curly constitutes a block. So a local variable is only alive from the point where it's declared until the close curly of the block where it was declared. It's short-lived. So put things there that aren't attributes, but are temporary calculations that you want to store for just a short term. Now we also have a concept called a parameter. A parameter is a variable that's in a method signature, and it's there to receive values that are passed to this method, often from another method during a method call. Now I'll show this a couple different ways. First of all, for reference, I'll show the Java look and feel quickly, and then after that we'll compare and contrast that to what it looks like in Kotlin. So here's a method signature that we're used to in Java. We have the access modifier public, return type int, method name add numbers, and then two parameters that are coming in. Then we have the work the method is doing, and we have what this method is returning. So local variable is int new num, and that is alive from the point where it's declared, which is right here, all the way down to the closed curly of the block where it is declared. So you see that this has essentially a very short lifetime. The parameter variables are what's getting passed into us when this method is called. Now let's take a look at a Kotlin equivalent. First of all, we'll assume public, so we don't have an access modifier there. Secondly, fun is a keyword that means function. In Kotlin, we tend to call them functions, not methods. Now we have the function name add numbers. The parameters you see here, kind of a little different syntax than what you might be used to. First, the name of the parameter variable, then a colon, and then the type. then a comma, then the next parameter name, and then a colon and the type. Similarly, you'll see that the return type also falls in a different location than you might be used to. This is int, which is the return type of this function. In the land of Java, we would typically put that on the left of the method signature, but you see here in Kotlin, we terminate the parameter list with a colon, and then we follow that with whatever the return type is. Now we have open curly and close curly, and you see within this we have yet another local variable, var. Var means this is a variable that can be reassigned. Val means it's a variable that's essentially final or constant and cannot be reassigned. But you notice we don't have to specify variable type, and that's because the type is implied. We see that we're adding two int types together, which means this is going to be an int type variable. And therefore, when we return this variable, it is indeed going to match the return type here of int. A package is kind of like a directory or a folder structure where we save our classes. Typically, packages are all lowercase, and it will often be a domain name in reverse. So if you think uc.edu, a good domain name would be edu.uc. But then that's not very unique, given that there are over 40,000 students at UC. So what we might do is something like edu.uc.bearcatid. Mine's JonesBR, so my package would be edu.uc.jonesbr. Then under that, I might have sub-packages for data transfer objects, or DTO. I might have them for DAO, for activity, and so on and so forth. So that's a package. Package we want to be unique so that we can use libraries from others and we don't have any kind of collision. That's why we often do a domain name in reverse to start something. Now, if you're registering a domain name for your project, probably a good idea because that is your unique identifier on the Google Play Store. So go ahead and grab a domain name if you want. They're fairly inexpensive. Then you could do something like com.plantplaces.dto, com.plantplaces.dao, so on and so forth, and you can have a structure that more closely matches your project. Now for class names, we'll typically name them in upperCamelCase. Notice that all of the words are put together without spaces and the first letter is capitalized. This is also known as Pascal case. So class name, always capitalize the first letter of every single word. Methods should always be lowerCamelCase. Notice the L in lower is lowercase. This is also just called CamelCase, but some people assume CamelCase means upperCamelCase. Some people assume it means lowerCamelCase, so I'm very specific here on which is which. For variables, we also want those to be lowerCamelCase. They should describe what they hold. Avoid using single-letter variable names unless you're within a loop where single-letter variable names are often accepted. Go ahead, spend the extra effort and name it something that's descriptive of what it holds. Not just for your fellow programmers, because they'll appreciate readable code, but also for you. If your code is readable, it requires fewer inline comments. But more importantly, you want to help your future self. In 1 year, in 2 years, you may totally forget why you wrote this line of code. But if it's readable, it'll be enough to kind of ring a memory, and then you'll remember what you were doing. So for everybody's use, go ahead and name your variable something fairly descriptive. We typically, we can't put spaces in variables. We can do some limited symbols. Most symbols we cannot do. One of the symbols we can use is an underscore. We don't tend to use it, though, except for one case, and that is constants. So constants are a special type of variable. They're declared final, which means once they're assigned, you can't overwrite it with a different value. It's a constant. It doesn't change. Oftentimes, this is used as what I'll call a fingerprint or a self-addressed stamped envelope in an asynchronous call with a callback. That is, you're calling something, you will eventually hear back from that something. When you eventually hear back from that something, it shows you a little fingerprint or a little key to say, here's the response you're hearing back from. That fingerprint or that key is something that you sent up when you initially made this asynchronous call. So we'll have some examples of that this semester, but nonetheless, that's where we tend to use constants. They tend to be somewhat frequent in the Android operating system. So once again, give them very, very descriptive names, and all uppercase surrounded by or with breaking with the underscore between letters. That's the naming convention we'll use for a constant. To the point, if you see a variable with that name, you can typically assume it is a constant. And if you're making a constant, you should use that so that people know what it is. So that's a look at some Android programming terms. I hope this video has been helpful, and we'll have several more that will help to get you started. I look forward to reading your comments. Thank you.